Hello, my name is Dan Oake, and I'm a student at Athabasca University, currently taking the course Computer Science 444, Embedded/Robotic Programming. And in today's video, I'm going to be showing you a live demo of my circuit, or correction, my coding challenge for circuit 5C, whereby I've created an autonomous remote control car that drives itself without user input and avoids obstacles via the ultrasonic distance sensor, the HC-SR04. However, through a remote control, I can also put it into remote control mode, whereby I can control it with directional arrows, or increase and decrease the speed, or stop it. Or I can also set it into RF transceiver mode, in which case I'd be able to control it wirelessly via a laptop and entering commands into the serial monitor. Now, in that mode, I do require a second Arduino. In this case, I'm using an Arduino Uno, or correction, Nano, and it's fitted with an NRF24L01 plus module with an internal antenna. You can see that's an internal antenna, and that's going to communicate wirelessly with the NRF24L01 plus external antenna version. So when I plug this in, it's going to automatically start in autonomous mode, and I'll be able to switch it into other modes using this. So the play button will put it in autonomous mode, the center button puts it in IR mode, and this red button will put it in RF mode. So without further ado, we'll get started. I'll plug this in. I've taken away the switch because I've ran out of I/O pins. I'm going to restart it. I'm going to press the restart just so we can see the setup. So the blue arrow indicated the RF transceiver setup correctly, and then the red, green, and blue LEDs indicated that the setup was proper. So it starts off in obstacle avoidance mode, where it drives on its own. Hello, my name is Dan Oake, and I'm a student at Athabasca University, currently taking the course Computer Science 444, Embedded/Robotic Programming. And in today's video, I'm going to be showing you a live demo of my coding challenge for circuit 5C, whereby I've created an autonomous car that drives autonomously without user input and does obstacle avoidance by using the ultrasonic distance sensor, the HC-SR04. However, for my coding challenge, I've also made it so that way it can be controlled via a TV remote, and it can also be controlled wirelessly via a separate laptop connected to a separate microcontroller, in this case an Arduino Nano, fitted with an NRF24L01 plus module with an internal antenna. So it has a range of about 100 meters, whereas the external antenna has 1,000 meters, but in either case, they'll work together in this tiny room. And the way that I toggle between the different modes is via commands on the remote controller. So it starts off by default in autonomous mode. If I ever want to go back to autonomous mode, if I take it out, I press the play button. To enter the mode where I can control it with remote controller, I press the OK button. And if I want to enter RF transmitter mode, where I communicate through the RF modules, I press the red button. So we're going to plug it in and get started, and I'll go through the different modes. So I'm just going to restart so you can see what happens. The blue LED flashes indicating the RF transceiver set up properly, and then the red, green, and blue LED flashed indicating proper setup. And now it's going to start off in obstacle avoidance mode, where if it comes up to an obstacle, it just turns. And then I can press this button. I press the center button on the remote control, and I put it into remote control mode. So now I can go forward, I can go backward, I can turn left, I can turn right, I can stop it by pressing either the pause or the stop button. Let me show you. So I'll go forward again, and then the stop button. I can press this blue button here and toggle on that blue LED. And that's pretty much it. I can drive and obviously if I was better at steering and stuff and not using a phone, I would control this a little better and do a little demo. But those are the options I have. I can also go back into autonomous mode if I press this play button. So I'm just going to turn it so that I am facing that direction. So now I'm going to go back into autonomous mode, pressing the play button. And I entered back into remote mode again because I didn't want to injure my son. So I'm going to go backwards, press pause. I'm going to press pause. And now, again, I'm still in remote mode, you can see. I'm going to enter the RF transceiver mode by pressing the red button here. You can see the LED is now blue because I'm in transceiver mode. And my son is going to type commands into here as I say. So type in the command F, 50. And press enter. Oh, here, I'll stop you for a second. We'll just restart this because it's been a while while I was setting up the video. Radio initialization failed. Let's just, sometimes this happens if you wait a while you're setting up the video. So we'll just reset this. And we'll re-upload the code. I don't know if I pressed that. So these RF transceivers can be finicky if you leave them for a while and the computer shuts down. So the mode isn't hooking up, so I'm just wondering if something got unplugged. I just want to hold that for a second. You can just show the screen if you want. The demo was working before fine, but I just want to make sure I didn't connect something off. Let's just rehook it up. Actually, two. Let's just hook it into this side in case it's the serial port. So go up to Tools, Port, make sure that we're connected to a port. So none of the ports are showing up just yet. X this. This is an issue sometimes with Arduino in general. If you leave it for a while, which I have, it sometimes disconnects. So just reconnect it. We're not changing any of the code because the code should be fine. I haven't made any changes to the code. I've just left the computer for a while. So we'll see this re-upload. It is saying there's some attempt issues. I wonder if I have another Arduino set up. Sometimes if you get this error, you want to go to the bootloader and here. You can just show that card for a second. I'm just going to re-upload the code. So I'm just re-uploading the code. I just don't want to have to comment out my files and stuff. So transmitter code, re-hooking up. So I just did a demo of the circuit and I went through the code and then I went up and took a break to play Mario Jamboree. And so during that time, I just left the computer on and it very well may have just kind of shut down, as it does from time to time. Actually, you can come show the code. I'll show something here. So occasionally I've noticed the Arduino IDE does this if you leave it for a while, and it's done it this time, where it gives me those errors saying that it's not, I've hooked it up to the right port. I've got the right, oh, actually, I see what the issue is. I keep pressing, so this is a dumb issue. It's hooked up for Arduino Uno because that was the last thing hooked up to it. So it's hooked up to Arduino Uno right now. And it's an Arduino Nano board, so that's why it's not connecting. So again, this is an Arduino Nano, but the last board I had hooked up was Arduino Uno, and for whatever reason, I just wasn't paying attention that I was having issue. That's why I was getting all those errors. So I'm still getting the errors, so there still might be something else wrong. So with the Nano, oftentimes you have to go up and hook up through an old bootloader, and that should get rid of some of these errors. So it's fine when we get stuff like this. Obviously makes the video a little longer, but these are common issues that happen. I had the wrong board selected. I had Uno selected because the other board that I'm using is an Uno. And because now I'm using a Nano, oftentimes you'll want to hook it up through the old bootloader. It's just kind of a thing. If you use the Atmega 328P bootloader by itself, it often doesn't work, and you need the old bootloader. So you have to specifically change that. Now that we've hooked everything up properly, the program should work good again. Again, we're in the regular program. There's no issues. Radio's set to transmit code. You can see that. So we should be good to go. So now, if my son takes back over the steering wheel there and types in the command F,50 and presses enter, our thing moves. Now press B,50. Okay, now press L,100. So see, it just turned left for a while. Press R,50. It'll turn right for about half that time. Now press T, enter. T, enter again. So the T simply toggles the red LED on and off. So press T, enter a couple more times. Okay. And now press F,100. And B,150. Okay. And so now I'm going to take the remote control. So that's how it works in the RF transceiver mode. Now I'm going to put it back into remote mode using the remote control. And remote mode is this middle button here. So when I press the middle button, I went into remote mode. We have a visual indicator that we're in remote mode by the red LED. So now again, I'm controlling it. Really hard to look at the phone and the car at the same time. And again, I could press pause, or I could have also alternatively pressed stop. Just going to widen the view here so I can see it better in the computer. Again, I can toggle the blue LED on via this blue button. Forward, back, left and right, and pause. Actually, I was pressing the center button, not pause. Again, if I press I'll give myself some room actually. I'm going to back up. Oh, stop just in time. And I'm going to do a test drive. So if I press this green button, it's going to go through sort of a function test without me doing anything. So if I press it, I press the green button, and now I'm going to do a function test. It goes forward so much. It's going to go backwards a little bit. Again, I'm not controlling it at this point, nor is my son. Might have to move because it goes back further. And now it accelerated, and it's going to go forward again, possibly hitting the wall. Okay, so if you're watching the video thus far, you'll notice that I just ran into a wall. Why did that happen? Well, because let me just start this. I put on, I started my robot car, which starts in autonomous driving mode. So when we start it up, the blue light flashes indicating that the RF module is okay, and then we flash red, green, and blue, all the LEDs indicating that setup is okay, and then we start in autonomous driving mode, where it will drive forward until it reaches an obstacle, in which case it goes back and turns. I was also able to put it in remote control mode, pressing the center button, And you can tell that it's in remote control mode because the LED switched from green to red. And then I can control it via the directional arrows. I can also pause it, stop it, press the stop button. I can toggle a blue LED on and off. And one of the other things I can do, I can obviously switch back by pressing the play button, switch back into autonomous driving mode, where again, it's autonomous driving. I'll go back into IR mode. I can go into RF transceiver mode by pressing this red button. And now, Ethan, enter command F50. And I'm driving forward. Press B, 50. And press T to toggle the LED on. Press T again. Now I'm going to go exit out of RF mode by going back into remote control mode by pressing this. And when I was in remote control mode in the previous video, I wanted to do a test function mode where if I press the green button, it goes through a bunch of function tests. It goes forward, stops, goes backward, stops, increases the speed to full speed, goes forward a lot further. And I remember that I made a comment, if you do the function test, make sure you have room, because for my function test, I had a little bit of room. And I forgot that part, and I ran into the wall. So this is after I ran into the wall, about a minute later, and we'll do it again. But this time, I've got it up on, blocks. So function test, pressing the green button. It goes forward so far, stops, goes backward so far, stops, increases the speed, so it goes forward really quick, which is what happened last time when we hit the wall. And then it's turning. It's doing right turns and left turns and different things. So you can tell the wheels are going in opposite directions possibly in the video if you pause it and slow it down. And that's the function test. So the function test worked fine, except for I didn't have enough distance and, ran into a wall. But again, that's how the car works. So that's pretty much it. Again, I can go back. The main circuit without the coding challenge was just to have it in autonomous mode. So let's put it back with the play button. Oh, I'm in the way here. And I'm going to put in remote control mode. And that's it. Let's just spin ourselves out. Actually, Ethan, before we go, I'll have you, I'm going to put it in IR mode, RF transceiver mode, and press F, 25. And T again. And that's it. Okay, one last quick video and live demo. So this is the autonomous robot car I created for the coding challenge for 5C, where it starts off in autonomous driving mode, and then I can toggle it via a remote control into IR mode and RFC transceiver mode. And right now I've got it in IR mode because I want it stopped. And this is a previous remote control car I'd made for Circuit 5C that, I can also put in IR mode. I don't have the RF transceiver mode hooked up. And it did autonomous driving, although not as well because I've got one ultrasonic sensor for a very wide base. But the difference with this one is I included an RFID tag where I couldn't enter the remote control mode unless I scanned it with an RFID tag. So we're just going to have these two fight it off. So if you turn that on, I'm going to let this go into play mode. It's seen that and got scared. Pathetic. Pathetic. We won't even fight. Go fight. Oh my gosh. Oh my God, they're not going at all. Okay, so this is the battle of my coding challenges for Circuit 5C of the SparkFun Inventors Kit Guide. So I had made this little robot car first by recycling one of my kids' sandwich containers. And I won't bother pulling that up, but there's a lot of stuff under the hood, including an L298N motor driver. So a very, not as efficient motor driver as the TB6612FNG motor driver that I have on this. But nonetheless, for the most part, a lot of it is the same. They both do obstacle avoidance via an HC-SR04 ultrasonic sensor. They both have IR receivers for remote control. And this one is fitted with an RFID tag reader, meaning I can't enter the remote control mode without scanning it with a card or a blue RFID tag. I technically do have an override, I believe, to enter it, but we'll use the tag. And this one I've got right now stopped in remote control mode because I wanted to wait. But now we're going to battle them. I'm going to turn this guy on, and then I'm going to set this guy free by pressing the play button, putting it back in autonomous mode. And that's what we're going to do. So that guy's on. That guy's in motion. Oh, I did it too quick before this guy could start. Now they're going to chase after each other. They're nowhere near each other. I'm going to restart this guy. Go attack. You know what I'm going to do? I'm going to enter this guy into IR mode. Oh. I'm going to enter this guy into IR mode by scanning the tag, and now I can pause it. Now this guy's in IR mode, and I'm going to see if they run into each other. Or I'm going to chase them. I'm not a good driver, especially with the phone. Oh, Ethan, I can't drive this at all. Oh, I got it into a corner. I'm going to enter the other guy in IR mode now. And now I'm controlling both. I'm putting it back into auto detection mode. And I'm driving this guy. And it doesn't seem like this fight is going to happen. Maybe they're both pacifist. But anyway, that's Circuit 5C in my coding challenge. So, and this was my previous circuit, which really just had the extra RFID that if you scanned it, I'll just turn that on again. If you scanned it, you could enter IR mode. So that's all that it did. But I don't have the remote. And again, stop this guy. So thanks for watching.